Next up is going to be number 7. Which is mixed numbers. First step is to convert the mixed numbers. 2 times 4 is 8. 8 plus 3 is 11. 1 times 9 is 9. 9 plus 7 is 16. Then my job is to come up with a common denominator. I'm going to go to use method 1 here. 4 times 9 is 36. Then I'm going to convert both fractions to have a denominator of 36 times 9 times 4. My two new fractions are 99 over 36. And this one is going to be 64 over 36, and 99 is also very much bigger, 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 bigger. Next, I'm going to do 8. Again, a mixed number comparison, which means I'm going to go ahead and convert them into improper fractions. 3 times 5 is 15. 15 plus 2 is 17 over 5. 4 times 3 is 12. 12 plus 1 is 13. 13 over 3. My common denominator using method 1 here is going to be 15. 5 times 3. Now I'm going to go ahead and convert both fractions. This one I have to multiply by 3. 3 times 5 is 15. This one I have to multiply by 5. 3 times 5 is 15. Which yields a 51 over 15 here. And it gives me 65, if my calculations are on there. So unless I messed up my calculations, 65 is bigger than 51. Alright, now I'm going to go ahead and move on to number, that was actually number 8. So I'm going to go ahead and move up to number 9 now. In number 9 I have 3 over 7, and I'm comparing it with a decimal. All I need to do is convert the decimal into a fraction. 0.6 is 6/10. And that's about it. My CD here, unfortunately, method 1 is the best way to go, and 7 times 10 is 70. Larger than I would like, but not much we can do there. To convert a 7 to a 70, I need to multiply both top and bottom by 10. At least it's an easy multiplication. Here I have to multiply by 7. Not too bad of a multiplication. 10 times 7 is 70. So I have 30 over 70. And I have 42 over 70. Which one's bigger? Easy. 42 is bigger. Alright, next up is 10. I have 0.3 and 3 over 5. Convert this into a fraction. This just comes down. Common denominator, method 2 here. The LCD for 5 is 5, 10, 15. For 10, it's 10, 20, and so on. You found one. It's 10. And something very neat. Since the LCD is 10, this one already is in that form. So I only have to modify this guy by multiplying it by 2. Which means 3 over 10 in comparison with 6 over 10. Which one's bigger? Easy. This one's twice as big. So 6 over 10 is indeed bigger. All right, moving on to number 11 now. Number 11, I'm comparing 0.25 and 1 over 4. 0.25, it's 25 hundredths, so it's 25 over 100. And obviously this is 1 over 4. I'm going to go ahead and do the LCDs here. I'll give you a hint. I'm not going to go through the process, but if you were to do all the multiples of 4, 100 would be one of them. So 100 is their common denominator, or the smallest one. In this case, this one already is at 100. How do I get a 4 into that same form? I have to multiply both top and bottom by 25, which then gives me 25 over 100. 25 over 100. They're the same. In this case, one is not bigger than the other. Number 12, which gives us our halfway point, is 1.2 in comparison with 1 and 2/5. 1.2 is the same as 1 and 2/10. 1 times 5 is 5. 5 plus 2 is 7, so this is 7 over 5. Again, I'm going to convert this into a mixed number. 1 times 10 is 10, plus 2 is 12 over 10, 7 over 5. The LCD for these two is 10, because I already showed you right here, between 10 and 5, it was 10. I have the same denominator, so I'm not going to go through the entire process. So 10, which means I only have to modify one of the two and not both. So I have 12 over 10 in comparison with 14 over 10. Well, that's the warning bell. And easy, 14. 14 is bigger than 12. All right, I'm going to go ahead and stop it here halfway through. I'll complete the other half later and I'll upload that video. So this is going to be a 4-part video. You'll have a lot of video material for the upcoming review.